Welcome to lecture 6 of module 5 on the subject ARM microcontroller and embedded systems. The subject code is 15EC or 17EC 62. So in the previous lecture we discussed about preemptive shortest job first scheduling algorithm. Okay, so how it will work, how it will decide which process is given the chance next to acquire the CPU and complete its operation or continue its operation. So that is what we discussed. So and in preemptive scheduling, what will happen is once you give the CPU or allocate the CPU to a process, so the scheduler has the authority to forcefully uh, take away the CPU from the process at any given point of time. Right? That is the concept of preemption or forceful deallocation. So in the previous lecture, we took an example and we discussed about how the processes are scheduled and which process will get the chance to execute when and for how much time, right? And we discussed about preemptive shortest job first, SJF, or least estimated completion time. So this scheduler works on the principle that whichever process is having less estimated completion time or least estimated completion time or least service time or least remaining service time, fine, so that will be given the chance to execute or to run using the CPU or to acquire the CPU. So and then we found out turnaround time TAT and waiting time and average turnaround time and average waiting time, correct? So now in this lecture, before going to the next type of preemptive scheduling, that is round robin scheduling, first we'll discuss the same preemptive shortest job first scheduling only with one more example. Okay, so before going to the example, we shall go through the definition of turnaround time and waiting time once again. So what is waiting time? Waiting time is the amount of time spent by a process in the ready queue waiting to get the CPU time. Okay, so nothing but in short, WT or waiting time is nothing but total time spent in the ready queue by a process until it completes. So until it completes, how much time it has spent in the waiting, how much time it has spent in the ready queue waiting to get the CPU. That is nothing but the waiting time. Fine. So next is turnaround time. So turnaround time is the amount of time taken by a process for completing its execution. So what is the total time it requires for completing its execution? So this time includes time spent by process for waiting for the main memory, that is to acquire the memory, then the time spent in the ready queue, the time spent on completing the IO operations, and the time spent in execution. So out of these four times that are included in the total turnaround time, so we in the previous example we had assumed that there are no IO operations and the processes are all ready. So that means the processes need not wait we need not wait for the for acquiring the main memory, so that is cancelled off because since they are ready, that means they have already acquired the main memory. So this you have to remove, okay, because this was the assumption in the previous problem. Next, time spent in the ready queue, so that is there because they have to wait in the ready queue to acquire the CPU. Next, time spent on completing IO operations, so this is not there. Why? Because the assumption was there were no IO operations. Okay, there were no IO operations, so hence time spent on IO operations can be removed from the turnaround time. So and remaining is time spent in execution. So only two times we have to consider these two parameters to calculate the TAT. So time spent in the ready queue is nothing but, what is this? This is nothing but the waiting time, WT, and time spent in execution. So how much time it spends in execution, so that is nothing but the service time. Okay, so time it spends in the for execution is nothing but service time. So this is service. So TAT can be given as so WT plus execution time. That's all. Fine. So you have to find out WT. So here and then you have to add the WT with the service time. So that will give the turnaround time for that process. Okay. Yeah. So with this basics, we shall move on to the problem now. Yeah. So this is the problem. So the problem can be given like this also. So can you see this? So what is given? So there are 5 processes: P1, P2, P3, P4, P5, and their arrival times are given. So arrival time for P1 is 0. So that means before the start of the execution, P1 has arrived. P1 is already present. So but P2 is arriving at 2 milliseconds. So let's say the time units are in milliseconds. Okay. So it is 2 milliseconds. For P3, the arrival time is 3 milliseconds. For P4, the arrival time is 5 milliseconds, and for P5, the arrival time is 9 milliseconds. Similarly, so one more column is service time. So the service time is nothing but the execution time. So what is the total execution time? What is the total time P1 requires the CPU to complete? So how much time P1 requires the CPU to complete is 3. Okay, it requires 3 milliseconds to complete. Remember this. So that is what is service time. P2 requires again 3 milliseconds of CPU time to complete. Okay. P3 requires 2 milliseconds of time to complete. P4 requires 5 milliseconds of time to complete, and P5 requires 3 milliseconds of CPU time to complete. Okay, so these are the service time. So the problem can be given like this also. Again, what you have to find out is you have to find out the schedule, that is which process is given the uh, chance to execute when and how long it will be given the time to execute, and then you have to find out waiting time for each process, then average waiting time, then turnaround time for each process, and average turnaround time. So all you have to find out. Okay, so again we are using Preemptive SJF. So whatever we discussed in the previous lecture, same concept but with a different example. That's all. So now again, so I'll write the so this will indicate the schedule. Okay, so which process will be given the chance when to execute. Okay, so I'll start with time 0. So in this case, so you can construct a table like this. So for the previous example also you can construct the table similar to this. So it will have 3 columns: time, processes, which process is scheduled. Okay, so these are the 3 columns. At what time, at whatever the time, what are the processes available, and among those processes, which one will be given the chance to execute. So that is what is scheduled. Okay, so we shall see this now. So first I will consider with time 0. So from that is where I have to start. Okay, so time 0. So time 0. So what are the processes available for us in the system or in the ready queue? Let's say which are the processes which are ready for execution. So if you see this table, so at time 0, you can see at time 0, which are the processes available? Only P1 is available. Okay, only P1 is available. Why? Because P1 is present in the system at time 0. No other processes P2, P3, P4 and P5 are present in the CPU at time 0, or they are present in the system at time 0. Okay, so only one process is present at time 0, and which is at process P1, because here P2 will come or will arrive at only 2 milliseconds, not at 0 milliseconds. Okay, so at time 0 milliseconds, fine, only P1 is available. So this time, so you can consider this in terms of milliseconds. Time in milliseconds. So at 0 milliseconds, which is the process available? Only P1 is available. And what is its uh, estimated completion time or service time for P1? So it requires how much time? 3 milliseconds. So that is what I'll write here. 3. Okay, so if you want, you can write 3 ms. or just 3, because we are considering the time in milliseconds. So it is 3. So hope you are getting this. So what you will write here in this column? So at time 0, which are the processes that are available in the system, which are ready to execute. So that you have to list here in this column. So for at time 0, only one process P1 is available in the system. So I'll write only one here, one enter. So now since only one process is available in which is ready, so that will be given the chance to execute. So P1 will be given the chance to execute. Okay, so hope you are getting this. Since there is only one system, there is no option. You have to give the chance to P1 only. I know this. Okay, so now you have given the chance to P1. So I'll write down here. So which is the process you give the chance? P1. Okay, so you're given the chance for P1 to execute. Fine. So how long will it execute, or how long will you give the chance for P1 to use the CPU? So that depends on when is the next process arriving. When is the next process arriving? So when is the next process arriving? P2 is the next process arriving, and when it is arriving? At 2 milliseconds after start of execution. So what is the next time interval you have to consider? Next time interval you have to consider 2 milliseconds. So that is what I wrote here. So at 2 milliseconds, which are the processes available which are ready to execute? Okay. Yeah. So which are the processes? So again, P1 will be available because here P1 requires how much? So P1 requires how much? It requires 3 milliseconds of CPU time, but you have given only 2, because from 0 to 2, so at time 2, your means a new process is arriving. So at time 2, okay, so P1 has not yet completed, because P1 will complete only at 3 milliseconds, okay, not at 2 milliseconds. Okay, so at 2 milliseconds, still P1 is available. So see, P1 is present in the system. Okay, so P1 is present in the system. Fine. So what is the remaining execution time of it? Or what is the remaining execution of remaining execution time of P1 at 2 milliseconds? So you have given the chance for P1 to execute at 0. So from 0 till 2, it is executing. Okay, so it has executed. So how much time it has executed now? 2 milliseconds. It has totally executed 2 milliseconds, but it requires 3 milliseconds to complete. Okay, it requires 3 milliseconds to complete. So still how much time it requires? So it is 3 minus 2 that you have already given, which is 1. Okay, so it is 1 milliseconds. So P1 at time interval 2 milliseconds still requires 1 more milliseconds to complete its execution, because total time it requires is 3. Fine. Okay. So which else process is present at time 2 milliseconds? Yeah, that new process that is present at 2 milliseconds is P2, because it has arrived at 2 milliseconds. So along with P1, there is one more process present in the system at 2 milliseconds, that is P2. Okay, and what is its service time? 3. So its estimated service time is, or completion time is, 3. Okay, so hope you are getting this. Fine. So I'll increase the font. So at 2 milliseconds, so there are two processes now. P1 with estimated completion time of, or remaining time of 1 millisecond, because since you already gave it chance previously, it has already completed 2 milliseconds out of 3 milliseconds. So the remaining time is 1 milliseconds for it. And then a new process has come up with execution time, or estimated execution time, of 3 milliseconds. So there are two processes. So now which process will you give the chance to execute? So based on the algorithm, what is the deciding criteria? Shortest job first, or shortest uh, or least completion time remaining. Least completion time remaining. So out of these two, which is having the least completion time remaining? Yes. So least completion time remaining is of P1 because it requires only 1 milliseconds to complete, but P2 requires 3 milliseconds to complete. So again, P1 will be given the chance to execute, or you can say P1 continues because already previously P1 was scheduled, and since you are scheduling P1 once again, so you can say that P1 continues its execution. Okay, so P1 continues its execution. Okay, so till when? So that is the next question. So till when? Okay, yeah. So till when means, so that depends on when is the next process arriving at the ready queue, or arriving at the which is ready. So when is the new process which is ready to execute arriving at 3 milliseconds. Now you can, so at 3 milliseconds, so at 3 milliseconds, yeah. Now we have to decide what are the processes in the system. So at 3 milliseconds, so now I'll write down here 3. Okay, so somewhere here 3 milliseconds. Okay, so at 3 milliseconds, what will happen is P1 actually completes its execution because it requires 3 milliseconds and you have given it 3 milliseconds of time. Okay, so from 0 to 3 means it is 3 milliseconds of time. So at 3 milliseconds, P1 completes. Okay, P1 completes. So what you can do is, you can add a new column here. So to your right, so insert a column right. So what will happen here is, you can keep track of completed processes. Okay, you can keep track of completed process. So time 3, which has completed, P1 completed, right? Then what are the processes that are available in the system at time 3 milliseconds? Now we shall calculate, we shall find out that. So at time 3 milliseconds, okay, so since P1 has completed, okay, P1 has completed, you have to remove P1. So you need not consider this P1 in 3 milliseconds because you have written it in the completed column. So which is the remaining? P2. P2 is the remaining, that is, it is ready to execute. Okay, what is the time remaining for P2? 3 milliseconds because you have not yet given it the chance to execute. So still it requires 3 milliseconds of CPU time to complete. So along with P2, so a new process has entered the system already, ready state, which is P3. Okay, so what is its estimated completion time? Only 2 milliseconds. So P3 with 2 milliseconds, okay, 2 milliseconds has entered the ready queue. Fine. Yeah. So are there any other processes? No. So at time 3, so now P2 and P3 are present. So that is what we have listed here, right? So hope it is clear. So this is how you write down the processes which are ready to execute. So out of P2 and P3, so according to the preemptive SJF, so we have to give the chance to whichever process which is having the least estimated completion time, or least uh, remaining completion time, or least remaining completion time, or least remaining estimated time. So out of P2 and P3, which is having the least completion time, it is P3, which is 2, but P2 is having 3. So P3 is having the least completion time, estimated completion time. So P3 will get its chance to execute. Okay, will get its chance to execute P3. Okay, so at time 3, P3 got its chance to execute. Okay, so hope it is clear. At time 3, so I'll write on time 3. Fine. So which is the process you will schedule? It is P3. So P3 is scheduled. Okay, and P1 has completed at time 3. Yeah, then what about the, you have given the chance to P3 to execute at time 3. Fine. Now till what time you give it chance to execute. So that depends on when is the next process that is arriving at the when is the next process that is arriving which is ready to execute. Because remember, in a shortest preemptive shortest job first, the ready queue will only be sorted whenever a new process arrives. Until then, the ready queue will not be sorted. Okay, so that is why I'm considering the arrival times. Based on the arrival time, I have to check which are the processes that are present in the system and which is having the least completion time, give it the chance to execute. So next process is arriving at 5 milliseconds. So I'll consider the next time interval at 5 milliseconds. Okay, fine. So at 5 milliseconds, what will happen actually? So at 5 milliseconds, let's say somewhere here, 5 milliseconds. So how much time P3 requires to complete? It requires 2 milliseconds of CPU time to complete. So you have scheduled it at 3. Okay, so since you have scheduled it at 3, and in the next time interval you are considering is 5. So at time interval 5, so P3 actually completes. So it completes off. So which is the completed process? P3. So at time interval 5, P3 completes. Okay. Now, which are the remaining processes then? So P3 is completed, so you need not consider it. So but P2 is still present, which is ready to execute. So you have to write it as P2, and still it requires 3 milliseconds of time to complete. So because you are not yet given the chance for P2 to execute. So at the same time, at time interval 5, one more new process has entered the ready state, which is P4. And what is its estimated completion time? 5 milliseconds. Okay, so P4, 5 milliseconds of estimated completion time has also arrived at time interval 5. So now according to the short preemptive SJF, you have to give the chance to the shortest or the least estimated completion time process to execute. So which is among P2 and P4, which is having the least completion time? It is P2. P2 is having the least completion time, which is 3, compared to P4, which is having 5. So now at time interval 5, okay, at time interval 5 milliseconds, you will give the chance to which one? P2. You will give the chance to P2 to start its execution. So which is the scheduled process then? At time interval 5, it is P2. Okay, so I am going slow because it is very important. This is the problematic part in this entire model. Okay, so and it will be asked usually for 6 to 8 marks. Okay, so we cannot neglect this. Yeah, so P2 gets the chance to execute at 5 milliseconds. Okay, so now till what time will P2 get its chance to execute? Okay, so that depends on again what is the next time interval. What is the next time interval? The new process is arriving. So uh, next new process which is ready for execution will arrive at 9 milliseconds. Okay, so that means can I write 9 here? No, I cannot write 9 because I cannot directly consider the time instant 9 because here you're given the chance to P2 to execute. Okay, and P2 how much time it requires to execute? It requires only 3 milliseconds time. So P2 actually completes at what time? So 5 plus 3 is 8. So P2 will complete its execution at 8 milliseconds. So the next time interval you have to consider is not 9 but 8. So either you have to consider the time interval that a new process arrives to the system, or you have to consider the time interval at which that process completes. So both. Only those instances you have to consider. Fine with this? Yeah, so at time interval 8, P2 completes because it requires only 3 time minutes, so it will complete. So 5 plus 3 is 8. So which is the process that is completed? Uh, Sorry, this one. Yes. Which is the process that completed? P2. P2 completes at time interval 8. So now at time interval 8, which are the processes that are present? So since P2 is completed, only P4 is left. So processes which are present in the system which are ready to execute at time interval 8 is P4. Okay, so it requires 5 milliseconds to complete. So is there any other process present? No, no other process is present at time interval 8 because the new process that is ready to execute will arrive at time interval 9. So at time interval 8, no new process is present apart from P4. So since only one process is present at P4, at time interval 8, so that process itself, that is P4, will get its chance to execute. So P4 will get its chance to execute. So P4 is scheduled. Okay, I hope you are getting. So at time interval 8, so P4 will get its chance to execute. So how long will P4 get its chance to execute? That depends on when it will complete, or when is the next process ready, that is ready to execute, enters the you can say ready queue. So when the new process will enter at time interval 9. So as soon as new process enters, so you have to decide on which process you will schedule. Okay, fine. So at time interval 9 now, so at time interval 9, so what will happen? So new process is entering. So along with new process, previous process is also present, which is that P4. P4, it has not yet completed, so it is still present, P4. So what is the remaining execution time of P4? See, actually P4 required 5 milliseconds to complete. So out of 5, you have scheduled P4 at 8 and now it is time interval 9. So out of 5 milliseconds, it has consumed 1 milliseconds here, right? So from here to here, it has consumed already 1 milliseconds. So out of 5, it has consumed 1, means the remaining completion time for P4 is now 4. Okay. So along with this P4, a new process has entered the system, which is P5. Okay, and what is its estimated completion time? 3 hours. Service time is 3. So it is P5 with estimated completion time 3 milliseconds. So now you have to decide out of P4 and P5 which one will you schedule based on preemptive SJF policy. So which is having the minimum time P5. So P5 will be given the chance to execute and no process has completed at time instant 9. Remember this. Okay, no process has completed. So you have to give the chance to P5. So at time interval 9, you have to give the chance to P5 to execute. Okay. So again, how long will you give the time for P5 to execute? That depends on either what time is the new process arriving or when is the process complete. So when will further there are no processes arriving after P5, no further processes are arriving. So once you give the chance to P5 and it requires 3 milliseconds of time to complete. So from 9, P5 will complete at 12 milliseconds. So the next time instant you have to consider is 12 milliseconds, and at 12 milliseconds, which is the completed process, P5. So P5 completes. Okay, hope you are getting P5 completes. So which is the remaining process? So only P4 remains, and what is the remaining time of its completion? 4 milliseconds. It requires 4 milliseconds. So since it is the only process present, it will be given the chance to execute. Okay. So at time 12, you are giving the chance for P4 1 second. So previously you had given the chance for P4 to execute, but it had executed only 1 millisecond because it was preemptive SJF and one more process P5 whose completion time is less than P4 arrived. So P5 got the chance. Okay. So P4 again will get the chance at 12. And what is the remaining time? So it is from 12. So the remaining time was 4. So from 12 so plus 4 it is 16. So P4 will complete at 16 milliseconds. Okay. P4 completes at 16 milliseconds. Sorry about that. Yeah, so next time instead you have to consider is 16 milliseconds. So which are the processes available in the system? No process is available. So all the processes are completed. So since no process is available, no process will be scheduled. Which will complete here? P4 will complete here. So hope you are getting. So this is the schedule. Okay, so I cannot erase this to some reason. Yes, so just consider till here. Okay, and this, I can shorten this. So this is the complete schedule from P1 to P4. So this completes the scheduling part, but still we have to find out the waiting time and turnaround time, right? Yeah, so how to find out that? So we'll come to that here. So same thing you can see here, a graphical representation of whatever the scheduling. Just go through it. So I leave this here, timing it, so you can pause the video and look at this. So say the graphical representation of this schedule, whatever we have discussed here. Same thing is displayed here. That's it. If it is confusing, don't worry about it. No problem. Okay. Yes, so now we'll talk about the waiting time. So we'll start with the waiting time. So we'll start with the waiting time of P1. So what is the waiting time of P1? So what is the waiting time? It is the total time spent in the ready queue by the process until it completes. So we'll come to this table now. So what is the waiting time for P1? So when the P1 has arrived, process P1 has arrived, it has arrived at 0, and you have given the chance for P1 to execute at time 0 itself. So as soon as it has come, you have given the chance. That means what is the meaning? No waiting time. And once you have given the chance to P1, it has completed its operation. It was never interrupted. Okay, it was never interrupted. It completed its execution. So once you have scheduled it at time 0, it has completed its entire operation. Fine with this? So hence the waiting time for P1 is 0. So because it has arrived at 0 milliseconds and you have given it the chance to execute also at 0 milliseconds only. So it has not waited at all. That is what is the meaning. Fine with this? So next is waiting time of P2. So how much time P2 has waited in the ready queue. So we shall see that. So when has P2 arrived? It has arrived at time interval 2. Okay, fine. It has arrived at time interval 2. But when have given P2 the chance to execute? It has arrived at 2. But when have given it the chance to execute? At 5. You have given it the chance for P2 to execute at 5. So it has waited, right? It has waited, obviously. It has come at 2. It was given the chance to execute at 5. And see the schedule here. Can you see P2 scheduled once again anywhere? No. So P2 is scheduled at 5 and it has not been scheduled anywhere else. That means P2, once you have given the chance to execute, it has completed. So it has completed at a single stretch. It has completed at a single stretch. So that means once you have scheduled it at 5, you have never rescheduled it. So it was never preempted or interrupted. So it has completed at 8. So now coming to the waiting time. So it has come at 2. Okay. So when it has come at 2. And when you have given the chance to schedule at 5. So that means waiting time for P2 is, okay, so it has come at 2, but you have scheduled it at 5. So it is 5 minus 2. Okay, so it is 3 milliseconds. 5 minus 2 is 3 milliseconds. So that is when, so sorry, that is the waiting time of P2. It has come at 2, but it has got the chance to execute at 5. That is what is the meaning. Right? So now we'll come to waiting time of P3. What is the waiting time of P3? So again, when P3 has come, it has come at 3. Okay, and when you gave it the chance to execute, you have given the chance to execute also at 3 milliseconds only. And Once you have scheduled, if you see the schedule, it is never rescheduled again. That means it has completed at one stretch. Okay, no rescheduling has happened. It has completed at one stretch. So from 3 to 5, it completed off. Fine. So it has come at 3 and you gave the chance to execute at 3 itself. So that means it has not waited again. So waiting time for P3 is also 0. Okay. So next, waiting time for P4. So P4. So when P4 has arrived, P4 has arrived at 5. And when you gave the chance for P4, P4 was given the chance at 8 first. Okay, and it executed till 9. And you can see P4 was preempted at 9 and it again was given the chance at 12. So now in this case, there are two waiting times you have to consider. Okay, so first waiting time is it has come at 5, but you gave the chance at 8, right? So now what is the waiting time then? So it is 8 minus 5 because it has come at 5, you gave it the chance at 8. So first thing you have to note down is 8 minus 5. Okay, plus. So plus, why I'm doing plus? Because P4 is scheduled more than once, so that is why there will be more waiting time. Again, so from 8 it was scheduled up to 9. So at 9 it was preempted because P5, whose execution time was less than P4, was given the chance. Okay, so it was preempted at 9. So from 9 till 12, again it waited. How much time? 3 milliseconds. So from 9 to 12, P4 again waited to get its chance to execute. So where it will wait? In the ready queue only. So it is plus. So it got the chance at 12 and it started to wait at 9 milliseconds. It started to wait from 9 milliseconds. So it got the chance at 12. So this will be the total waiting time for P4. What is this? So it is 3 plus, again it is 3. Totally, the waiting time for P4 is 6 milliseconds. Okay, so now the last one. So WT, waiting time for P5. So waiting time for P4, it was a very important calculation. If you want, you can go back and listen to the explanation once again. Okay, so now waiting time for P5. So when has P5 come? So P5 has come at 9. Okay, and when you gave the chance to execute, you have given the chance to execute at 9 itself. Okay, and in this entire schedule you can see P5 is never scheduled once again. That means P5 completes at one stretch. Okay, it completes at one stretch. Once you give the CPU, it has completed. Okay, so it has come at 9 and you have given the chance at 9 itself. So that means waiting time for P5 is also 0 milliseconds. Hope you are getting this, right? So now to calculate the average waiting time, so I'll open my calculator. Okay, yeah, so I have to start with 0. So it is 0 plus 3 plus 0 plus 6 plus 0. Okay, so it is 9 divided by how many processes are there? 5. So that is why how we have to take the average. So it is 1.8 milliseconds. Okay, so average waiting time. So the average WT is 1.8 milliseconds. Hope you are getting this, fine. So now we shall find out the turnaround time. So that is the next thing. TAT for individual process. So TAT for P1. So what is the formula for turnaround time? It is the waiting time plus execution time. That's very simple. So what is the waiting time for P1? We already calculated. It is 0 plus what is the waiting time for, sorry, what is the execution time of P1? Execution time is nothing but service time. It is 3. Okay, it is 0 plus 3. It is 3 milliseconds. Okay, so it is waiting time plus service time. So next, TAT for P2. TAT for P2. So waiting time for P2. Waiting time for P2 is 3 milliseconds. And what is the service time for P2? Go back to this table. Service time for P2 is 3 again. So it is 3 plus 3. It is 6. This is TAT for P2. So what about TAT for P3? So waiting time for P3 0 plus service time for P3. Service time for P3 is 2. So it is 2 milliseconds. Next, TAT for P4. TAT for P4 is waiting time for P4 is 6 milliseconds plus the service time for P4. The service time is 5. It is 6 plus 5, totally 11 milliseconds. And last one, so TAT for P5. What is the waiting time for P5? 0. Service time for P5, go back, is 3. Service time is 3. So 0 plus 3 is 3 milliseconds. So next is average TAT. So how will you take the average? So sum of all these values divided by 5. So I'll go to the calci once again. Yeah, so it is, I'll clear the entry first. Yeah, so it is 3 plus 6 plus 2 plus 11 plus 3. So it is 25 divided by 5. So it is 5 milliseconds. So the TAT is 5 milliseconds. Okay. So this is one more example with shortest job first. That is preemptive shortest job first algorithm. Okay. So we shall discuss about round robin scheduling and priority based preemptive scheduling in the next lecture. So hope this was useful. Go through it once again and understand it properly, because I'll not go this slow for the next two algorithms. Thank you.